what we see here is a thermometer. We have an uncalibrated thermometer taped to a piece of plastic on which is glued an accurate copy of a part of a meter stick. And I think I said it was glued. It's not glued. It's held by rubber bands. The thermometer is held by rubber bands. Now, you can see the column of mercury, or actually alcohol in this case, colored alcohol, and it's up to a certain point, and I can read that column in millimeters. And I can read the room temperature. This thing's been sitting in the room for a while. Actually, I just had it nice and it's a little damp, so it might not be exactly reading room temperature, but I can read the room temperature in millimeters on this scale. Now what you see here is a setup for the first experiment. I've got a couple of styrofoam cups. This cup is full of ice water, approximately equal amounts of finely crushed ice and water. This cup is full of room temperature water. It's been sitting in the room. The water is approximately room temperature. I can insert the thermometer into the ice and stir it around, and I can then read after a minute or so when the thermometer's come to equilibrium, and we want to make sure the thermometer has really stopped moving. We also want to make sure we don't have the rubber bands over the point where the thermometer is going to stop moving, and we've almost done that. And then we can read the thermometer down here near the rubber bands. Then we can dip the thermometer into the boiling water. Of course, you can boil water in a saucepan on your stove. You don't have to use a hot plate. And we can get a reading from the thermometer in the boiling water. Okay, so we read that. That's way up here someplace. It went from down here way up to here. So you can't see that, and I'm about to burn myself. We went from way down here way up to here. So we have a reading for room temperature, ice water, and boiling water. And then we're going to be able to assume that the temperature, whatever that is a linear function of the position on the thermometer. That is, for every centimeter or every millimeter the thermometer goes up, that corresponds to a certain number of degrees in whatever temperature scale we want to use for the experiment. So that's the idea of calibrating the thermometer. And then, of course, we can use the computer calibration as explained in the experiment write-up itself.